Hello everyone, as we know now the derivation of compensated demand curve and how to derive indirect utility curve or indirect utility function from ordinary demand function. Now we will see how we can derive ordinary demand function from indirect utility curve. How to derive ordinary demand function from an indirect utility function. So, in order to do that, we are going to learn a new topic. We can derive it using Roy's identity. So, what is Roy's identity? It is the ratio of partial derivative with respect to price and income. That is, if you want to find out the ordinary demand function of x, that is x star is equals to minus of delta v by delta px whole divided by delta v by delta m. Similarly, y star is equals to minus delta v by delta py by delta v by delta m, where v is equals to the indirect utility function. That is, v is equals to function of price and income. So from here, by taking the derivatives and taking the ratio of the partial derivatives, we can find out our ordinary demand function. So let's quickly have a look at one example. Let's say the indirect utility function is given by v is equals to m square by 4 px into py. So this is indirect utility function that is given to you. Now the question is, find the ordinary demand function of x star and y star, right? So let's have a look at the solution. First, let us write down the function that we are given, that is v is equals to m square by 4 into px into py. Now let us take the required partial derivatives. What are the partial derivatives we need? We need three partial derivatives. The first one is delta v by delta px. So how much is delta v by delta px? So this is m square by 4 into py. This remains as it is. So px is minus of px square. Next, delta v by delta py. This is again minus of m square by 4 px into py square. And finally we have delta v by delta m, which is equals to 2m by 4 px into py. So let us cut it, and lowest term is 2px by py. Now what we have to find out? We have to find out the ordinary demand function. So let's say by using Roy's identity, x star is equals to delta v by delta px whole divided by delta v by delta m. So that is equals to minus of, how much is delta v by delta px? We have just calculated. Let's go up, 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 and we have got minus m square by 4 py px square. Correct? into what is delta v by delta m this. So let us take the reciprocal of it. So that is 2px into py by m. Let us simplify. We get, so this is 2 gets cancelled, 2 gets cancelled, py gets cancelled, py gets cancelled, px gets cancelled, this square gets cancelled, this square gets cancelled, and this m gets cancelled, and we are left with m by 2px. So the ordinary demand function is m by 2px. Now similarly, by using the same formula, we can find the ordinary demand function for y, and that is y star is equals to minus delta v by delta py by delta v by delta m. Now that is equals to minus of, so in place of delta v by delta py, I can put the value as we have got here. That is minus m square by 4 px py square. Into what is delta v by delta m? So we are going to take the reciprocal because it is division. So we get 2m by px into py. So, okay, reciprocal, right? So this is actually this. Px py by 2m. Let's just revisit it. 2px py by m, sorry. Let us put the value. Two px py by m. Now square and m gets cancelled, px gets cancelled, py and this square gets cancelled. So what are we left with? Oh, also this is 2 and 2 2s are 4. So we are left with y star is equals to m by 2py. This is the ordinary demand function of y. So using Roy's identity from the indirect utility function, we can directly derive the ordinary or the Marshallian demand function. So this is our Roy's identity.